Okay, this is Honors Geometry Section 1-3, Segment, Rays, and Distance. Let's start with this page right here, okay? So, definitions and postulates is the second part of chapter 1, we're right here, okay? And for this packet, we have two objectives. This one and then part of this 3, the segment, addition, postulate. Okay, so use the symbols for lines, segment, and rays, and distances, and find the distances. Okay, and then state and use the segment, addition, postulate. Now, I think the word postulate is new to you, so we talk about that a little bit later. Now, there is another postulate called angle addition postulate, and this is in section 1-4. Okay. All right. So, key concept: the segment and rays. So, we learned the line, right? Line is in this symbol. And now we are adding the concept of segments and rays, okay? So in the diagram, point B is between point A and C. Note that B must lie on line AC. These 3 points are collinear. Segment AC, denoted by AC with a line above, which is different from this, right? Consists of points A and C and all the points that are between A and C. Point A and C are called the end point of segment AC. Okay, so that's the segment AC. It's all the points that starts with A and end with C, all start with C and end in A. All the points represented by between these 2 points is segment AC. Ray AC, on the other hand, denotes with this kind of sign, which has one arrow on one side. Consists of segment AC and all other points P such that C is between A and P. What it's trying to say is that ray AC start with A and then go to segment P, and then it also includes all the points to infinity in that direction, into the C direction. Okay, the end point of AC is A, and that point name is first. Okay, so they call it end point, but it's kind of like a starting point of ray. So it starts here, and then all the points on the other end, inclusive, is ray AC. Okay, here is the opposite rays. SR and ST are called opposite rays if S is between R and T. So these rays are starting at R and includes all the points towards the R direction. And this ray is starting at S and includes all the points in the T direction. If S is between R and T, the direction have to go in the opposite, right? So starting here and then all the points in this way, starting here, all the points in this way. That means the points in ray SR and points in ray ST are not overlapping except the point S only. And those are called opposite rays, okay? Also, the ray TS would be starting at T and including all the points on direction S. So the ray is, this symbol is always facing this way, even though in the diagram the ray is going that way, okay? And then ray ST is starting at T and all the way this way. Ray TS is starting at T and all the way this way. So ray ST and ray TS are not the same. They are not the same rays. Okay, well, later you learn that this is actually, to be more strictly, they are not congruent. Okay, that's a congruent sign. Okay, now we are talking about distances, so we have to give a numerical value to these points. Okay, so on the number line, every point is paired with a number and every number is paired with a point. In the diagram, point J is paired with -3 and the coordinate, and the -3 is the coordinate of J. Okay, so that's a coordinate of this point, the coordinate of k is 0, coordinate of m is 4, so forth. Okay? So the length or distance, the length of segment MJ, you can take the distance. So m is 4 and j is -3. So 4 minus -3 is 7. It's, if you have a number line, you can just count it 1, 2, 3, 4, 5, 6, 7. The distance mj is 7. Oh, by the way, the symbol for distance is nothing on top of it. Okay, so when there's nothing on top of it, that's the distance between 2 points. Just a line, that's a segment. This is ray, and this is line. Okay, so those are the symbols that we learned so far. Okay, and when you're taking the distances, let's say, for example, k and j, so 0 minus -3 is 3, so distance is 3, and so forth. So you can take a subtract one number from another, and then if the number is negative, take absolute value, because we are talking about the distance. Okay, now here are two postulates here. The postulates are the as opposed to theorems, postulates are things that are accepted as truth without proof. Okay, all right, so ruler postulate. So this is accepted as a truth without proof, which in mathematics terms, it's not ideal. We want to prove it if we can, but we have to start with some postulates so that we can use those postulates to build other theorems on top of it. So these are accepted as truth without proof. That's what the postulates are. The points on the line can be paired with real numbers in such a way that any 2 points can have a coordinate 0 and 1. So the ruler postulate is that at any point on the line, you can assign numbers to it. Once a coordinate system has been chosen in this way, the distance between any 2 points equals the absolute value of the difference of their coordinates. It's a postulate because it's kind of common sense. Okay, now segment addition postulate. If B is between A and C, then the distance, so B is between A and C. Okay, the distance between A and B and distance between B and C have to equal distance between A and C. Okay, that's what this is. Again, it's kind of common sense. All right, here's the example. So this example, find the value of x and the distance between B and C. I want you to do these as a homework from the video. Okay, now I think you can do this. Okay, that it's just saying that AB plus BC have to equal AC, so use that. All right, congruent segment. In geometry, two objects that have the same size and shape are called congruent. For many geometric figures, we can give a more precise definition of what it means to be congruent. For example, we will define congruent segments in this section, congruent angles in the next section, congruent triangles in chapter 4, and so forth. So congruent is coming up a lot in the first half of this course. Okay, so the congruent segments are segments that have equal length. Okay, so if it doesn't have to have the same orientation or same location, as long as the distance between the 2 points are the same, the segments are congruent. That's a definition of congruent segment. Okay, so these two segments are congruent because the distance are the same. Okay, and then this is the congruent mark. Okay, so that means the shapes are the same. This means that the size are the same. Size in this case are the distances. Okay, in the shape for the segment, there is only one shape because it's just a line. Okay, and this is called segment DE is congruent to segment FG. Right, and then the midpoint of a segment. The midpoint of a segment is a point that divides the segment into two congruent segments. Okay, so if P is a midpoint of AB, then it will cut the segment AB into two congruent segments, meaning the segment AP is congruent to segment PB. You can reverse the order of segments, and then it's still the same thing. So you can also say the segment AP is congruent to segment BP, and that's the same thing. Okay, you can also reverse the order of line. So line AP and the line PA are the same thing, but you cannot reverse the lay. Lay AP and lay PA is not the same, because lay AP is this. That's a lay AP. Lay PA is this. Startup pay and includes all the infinity through A. These are not the same. They are not congruent. Okay? Alright. And the bisector of segment. Bisector of segment is a line, segment, ray, or plane that intersect the segment at its midpoint. Okay, so midpoint is the point that cuts the segment in half. And anything, for example, this point is a bisector. It can be a line, it can be a plane. Anything that cuts the segment in half is a bisector of a segment. Okay? So for example, if the P is a midpoint of AB and then the line L go through a P, then this line is a bisector of segment AB. Alright, let's do a couple problems and then we are done with this video. Okay? So, let's see. Does the symbol represent a line, segment, lay, or length? Okay, you can do this one. How many endpoints does a segment have, ray, or line? This is a good problem for you to think through so that you understand what those lot of definitions that just came out. Okay, is a segment AB same as segment BA? They are the same. Okay, so this is true. Yes, I guess yes. Is ray AB same as BA? No. The lay AB is this, lay BA is this. They are not the same. Line AB and line BA is the same. Yes, they are the same. Okay. Is distance AB the same as distance BA? Yes, the distance between these 2 points should be the same. Okay, so only thing that you cannot flip is the ray. Cannot flip points. Okay, all right. What is the coordinate of P and R? Okay, you can do this one. Name the point with coordinate 2. Coordinate 2 is a T. Find each distance RS, RQ, and P. You can do this one. And name 3 segments congruent to PQ. Okay, so the segment PQ has a distance of 1. So any segment that has a distance of 1 are congruent. So segment QR is congruent, segment RS is congruent, segment ST is also congruent. And you can express those segments in the reverse order. So segment TS or segment SR, segment RQ. However, segment TR is not congruent to segment PQ because the distance here is a 2 and that's a 1. Okay? And name the ray opposite to SP. SP, so lay opposite to SP is lay ST. Okay, so that's sharing the S as a starting point, going one direction and going the other direction. Name the midpoint of PT. Midpoint of PT, I think you can do this one. And what number is halfway between 1 and 2? Halfway between 1 and 2 is 1.5, right? What is the coordinate of the midpoint of ST? Coordinate of the midpoint of ST is also 1.5. Or so 1.5. Or you can do yeah, let's just leave it at 1.5. All right. Could you list all the numbers between 1 and 2? All the numbers, so you can't because there are infinite points in here, right? So no. Is there a point on the number line for every number between 1 and 2? Is there a point on, yes, every point has a point on the number line. Every point can be corresponding to one number, so this is yes. It's just that you cannot list it because there are infinite number of small numbers between. Is there any limit to the number of points between S and T? No. There are infinite numbers between those two. Okay. Right, we're done. Okay, any part that was confusing in this packet, we will go over in the class, and then we will work on the rest of the packet in the class. Just do these and make sure you do the survey.